All right, the last rational number that we're going to look at is a fraction. So all rational numbers can be written as fractions, and if they can't, then they're not considered a rational number. They'd become irrational. So pi would be an irrational number. But fractions are just division problems where you divide the numerator by the denominator. Or the numerator is the dividend and the denominator is the divisor. So all fractions, so numerator's on top, denominator's on bottom. So to find out what this would be as a decimal, you just take the dividend out front and the numerator under the bracket. And you go through those steps to solve. You can also put this in a calculator, just the top number divided by the bottom number. Now all fractions are, when converting from a fraction to a decimal, they are going to either terminate or repeat. So when you solve, eventually you're either going to run out of anything to bring down and it cancels out evenly, or you're going to find a number that just keeps reappearing, and so that number repeats. So how this looks, so we've got 5/8, so we want to divide. The top number goes under the bracket. The divisor or the denominator goes out front. Now you notice that the denominator is bigger than the numerator. This means that our answer is going to be less than 1. So we know that 8 cannot go into 5. So I put my 0 over my 5, and then after every number there's an infinite number of zeros that follow it after the decimal. So we've got our decimal, so there's a bunch of zeros. That's not going to change the value of that 5. Okay, so now we're looking at how many times can 8 go into 50. So now we've used one of these zeros. Well, 8 can go into 50 6 times. 8 times 6 is 48. When you minus, you're left with 2. Bring down the next 0. So now 8 can go into 20. And notice how I keep putting my number above the place value that I bring down. This just helps it, it keeps easy to follow and organize. So I know exactly where the decimal should be and what place value I'm going to. Okay, so now 8 can go into 20. That's 2 times. That would be 16. That would leave me with 4. So now this would be the 1,000th place. So 3 places after the decimal, I bring down that 0. Now I've got 40. 8 can go into 40 5 times. Okay, so now I end in 0. There's nothing else to bring down other than zeros. So this now has terminated. So now to rewrite my 5/8 as a decimal, that would be 0.625. Okay. Okay, so we'll do that again. Same thing with 3/5. So once again, the top number goes under the bracket. The denominator goes in front. Okay, 5 once again cannot go into 3. So that would be 0 times, but now we can go into 30. Well, 5 goes into 30 6 times. 6 times 5 is 30. We get 0. Okay, it's just 0, so this terminates at 6. So then to rewrite 3/5 as a decimal, it would just be 0.6 or 0.6. Okay, so these two, they terminate. Let's see this next one, and now this one's a negative. So the only thing that tells us is that we're dividing a negative by a positive. So there's an odd number of negatives, so our outcome is going to be negative. So I'm going to set it up. Top number goes, it's -2. And so I'm just going to bring this negative up here because I know that if there's an odd number of negatives, my outcome is going to be negative. Okay, once again, I'm going to bring my infinite number of zeros behind the decimal. Okay, I know that 9 cannot go into 2, so that would be 0. I bring up my decimal. So now I'm going over to this 2.0, so 20. 9 can go into 20 twice. So that would be 18. So 20 minus 18 is going to leave me with 2. Going to bring down my 0, and I'm going to get 20 again. Okay, so what we're going to see is that this would be 20. And now you can go into 20 2 times, so you get 18. And so this is going to keep repeating. So I'm going to put a bar over to note that these numbers are going to repeat. And you don't have to do 22. You could just say negative 0.2 repeating. But that would be the other instance. It doesn't terminate, but it keeps repeating. Okay, so that's converting fractions into decimals. So it's just division. You can use a calculator and just divide the top number by the bottom number. Fractions are just division problems. Okay, so now if we want to convert decimals to fractions, so now we're working in reverse. So this is where you're going to note the place value. Okay, so this number, 0.125. So this is the tenths place. This would be the hundredths. And this would be the thousandths. Okay, so if this is carried to the thousandths, what we do is we make it a whole number, so 125, over the number of the place value. So it would be it goes to the thousandths place value. So it's going to be 125 over 1,000. So we've got our fraction, but now we want to simplify. So you look for the greatest common factor of 125 and 1,000. Well, I know 25 goes into both of those. So I'm going to divide both top and bottom by 25. This is going to simplify my fraction to a smaller term, and then I'll see if that is indeed the smallest term. If not, I can always go back and simplify even more. So 125 divided by 25 is going to be 5. And 1,000 divided by 25 is going to be 40. Okay, so let's see, is that correct? Yes, because 25 times 4 is 100, so yes, 40. Okay, so this can be simplified even further. 5 can go into both of them. So now 5 divided by 5 is 1. 40 divided by 5 is 8. So there we've simplified this this decimal right here. We convert to this fraction, then we simplify all the way down to 1/8. So 1/8 is it in simplest form. And if you took 1 divided by 8, you would get 0.125. All right, so 2 more examples. So same thing. We're going to write this as a whole number, so 38. We are out here in the hundredths place. Not hundredth, but hundredths. So we're going to put this over 100. Okay, and now this is not in simplest form because I know that 38 and 100 are both even numbers, meaning that they can be divided by 2. So if I do that, I get half of 38, which is going to be 19. And then half of 100 is going to be 50. Okay, so now I know 19 is a prime number, so there's no common factor of 19 and 50. So this is in simplest form. Okay, last one. So this is a negative 0.625. So once again, it goes to the thousandths. Okay, so I'm going to make this a whole number and put it over 1,000. And now I put the negative on top. It could go on the bottom. Either way, it's going to have the same outcome. It doesn't matter if you're dividing by a negative 1,000 or if you're dividing a negative by a positive 1,000. It's still the same number. But okay, once again, I'm looking at this, I'm going, I know 25 can go into both of them. So I'm starting with that as my common factor, and then we'll reduce from there. So 6 can go into 625. That would be 5 times. Nope, that's not 5 times, sorry. It goes into 100 4 times. 4 times 6 would be, nope, sorry. It can go into 100 4 times. So 4 times, oh, sorry. Okay, you can go into 104 times, and there's 600, so that would be 4 times 6, which is 24, plus another 25, so that's 25. Whoops, come on. Okay, 1,000 divided by 25, so I can use up here, notice it was 40. Okay, and once again, that was not the greatest common factor because 5 can go into both of these. So I'm going to divide both by 5. Well, 25 or a negative 25 divided by 5 is going to give me a negative 5. And 40 divided by 5 is going to give me a positive 8. So there we've reduced it all the way down to negative 5/9.